Hello. Okay, so today we will be doing 5.3, which is solving trig equations. Okay, so what we're moving on to is instead of having an identity that we're going to use different identities in order to verify, we will be actually solving them. So getting an actual x value for some of these trig equations. Okay, so what we're going to start off with is kind of an easier one here. So we will be doing 2 sine x minus 1 equals 0. Okay, so the end goal here is we want to try to solve for x. In order to solve for x, we first have to try to get sine by itself. We want to isolate sine. So we can almost cover this up and act like there's just the x there. If this was 2x minus 1, how would you try to solve this? The first thing you would try to do would be to add 1. And again, what I'm saying is compare this to 2x minus 1, taking that sign out of the equation. The first thing you would do would be to add 1. So we want to add 1 to both sides. This is just basic solving two-step functions here, so two-step equations. Adding 1 to both sides is going to give us sine x equals 1. So again, think about this with no sign there, just 2x equals 1. You would then divide both sides by 2 to get sine x equals 1/2. Okay, so what we said in the beginning was we want to actually get an x value. So we said first you have to get a sine value or sine isolated to then go ahead and get an x value. So here we have that sine isolated. We want to actually solve for x now. That's going to need our unit circle. So if you don't have a unit circle handy, make sure you grab one or Google one online. And what we're doing is using this unit circle in order to evaluate for sine x equals 1/2. So one thing we want to note is that the period of sine is 0 to 2 pi. So when we're trying to look for sine values, we go all the way from 0, all the way around this unit circle, back, marked my paper, back to 2 pi. So we can look over the entire unit circle to try to find these values. So again, we're looking for where sine equals 1/2. So when we see unit circles, they have coordinate pairs within them. Coordinate pairs are generally talked about in XY terms. We say an XY coordinate pair. In this case, it still goes alphabetically XY, so it goes cosine sine. So when you're looking at any of these coordinate pairs, the first one is cosine, the second one is sine. So if we are trying to figure out where sine equals 1/2, we want to determine where is sine a positive 1/2 on the y coordinate of any of these coordinates along my unit circle. So if we kind of go around, the first one just on the top half that we see is right away. We see in our y coordinate a positive 1/2. That value is at pi over 6. So first we can say x equals pi over 6. But there can be multiple values. There can be up to 4 values for each of these. So we keep scanning around and keep scanning around, and then over here, we have another positive 1/2 in our sine value at 5 pi over 6. So that is our next sine value, x value here. Okay, so if we keep going around, I'm going to see a negative 1/2, and I keep going around and I see negative 1/2. So that's the end of my solutions here. Once I go all the way around, I can't find any more. That's when I am able to say, yep, these are my answers. Okay, so here, some of these are a little bit easier. So let's get into maybe some of the tougher ones for this. Okay, let's try sine x plus root 2 equals negative sine x. All right, so again, I want to try to just solve this by getting all terms on the same side. If I can get something set equal to 0, I'm going to have an easier time solving it. So the first thing I'm going to do is add sine over. I want to remind you when we're working with trig functions, it's just like having any other variable. If I had an x plus an x, just like I have a sine plus a sine, right? X plus x is 2x. So sine plus sine is going to be 2 sine of x. Still equal or plus root 2, now equal to 0. So this root 2 is just like any other number. Okay, root 2 is actually some decimal, but when represented in a square root or in a radical, we can treat it as any other number. So if I want to get rid of this, I can still subtract root 2, giving me 2 sine x equals negative root 2. In order to, again, solve for sine, I need to divide everything by 2. Okay, the end goal is always, what did I want to use sine? Yeah, I want to use sine. We just want to try to get that trig function by itself. So dividing by 2 cancels over here, giving me sine x equals negative root 2 over 2. Okay, so once I get my sine or my trig value isolated, I say, okay, it's by itself. I need to now go use my unit circle to actually evaluate this. So thinking about the fact that, again, it's cosine sine, that's a weird parenthesis, sorry about that. On our unit circle, I pull my unit circle back out and we'll say, all right, now how can we solve for this? So again, we already said that sine is our y value. So we want to know, where is sine a negative root 2 over 2? If we're going our way around, in this first quadrant, they're both positive. Second quadrant, my x is negative, but my y is still positive. So looking down here, I have a negative root 2 over 2 in my sine, so 5 pi over 4 is one of them. If I keep going, I have another negative in my y, which at 7 pi over 4. So 5 pi over 4 and 7 pi over 4 are going to be my answers here. So I write x equals 5 pi over 4 and 7 pi over 4. And that would be your answer here. That's a 7. I know it's a little goofy. That's a 7. Okay. So while we can solve these for sine and cosine, we also know how to solve these for tangent functions. Tangent, as far as we're going to go, we will not get into doing this with cotangent, cosecant, secant, or any of that. Tangent, again, will be as far as we go with this. But it's a little bit different way of solving it. So let's say I have 3 tangent squared x minus 1 equals 0. So we have to now isolate the tangent function. So I'm going through here, add 1 to both sides again, because I'm covering up this tangent. I'm imagining that there's an x there. So if I want to get this x by itself, I'm trying to get any addition or subtraction away first, giving me 3 tangent squared x equals 1. Next step is going to be dividing everything off, dividing by 3 to give me tangent squared x equals 1/3. Okay, those are the easy steps, right? Getting rid of any addition or subtraction, getting rid of any division or multiplication. Now what I can do is get rid of the square. So a couple of things with this. A square root is going to get rid of a square. So I need to square root both sides. And on this side, it's lovely. It cancels and I get tangent. On my right side, however, I'm taking the square root of a value. I want to remind you, when you're taking the square root to try to find that x value, you have to put in this plus or minus symbol. So what a plus or minus symbol represents is the fact that when we take something out of a square root, we do not know if it was positive or negative. That being said, this 1/3, in order to achieve that 1/3, it could have been 2 numbers that were negative multiplied together to make a positive 1/3, or it could have been 2 positive numbers multiplied together to get this positive 1/3. Okay, so that's what we're saying when we have a positive or negative. For example, if I take the square root of 4, that answer would be plus or minus 2. You could have negative 2 times negative 2 to get positive 4, or positive 2 times positive 2 to get positive 4. Okay, so the plus or minus is super important here. We can't make assumptions that it was positive or negative. Okay, so adding in our plus or minus, another huge thing we can do with square roots is when we're taking them of a fraction, you can actually split this up. Okay, this property is associative, so no matter which way you group it, it's still going to be the same value. You can take the square root of the entire fraction, or take the square root of the numerator and the square root of the denominator separately, and then divide, and you'll still get the same answer. This will help us here because I don't know what the square root of 1/3 is, but I do know that the square root of 1 is just 1. Square root of 3 is a really gross number, so we leave it as a square root of 3. Now, usually, if we have a root in our denominator, any kind of radical, we want to get rid of that. So we try to rationalize the denominator. In this case, we do not want to do that because this is not our final answer. This is a step to get us to our final answer. So I don't need to simplify this. I don't need to rationalize my denominator. In fact, if I did, it would make my life a little bit more tough to try to get to my final answer. Okay, so we have to think in terms of if I'm trying to find tangent, and you look on your unit circle, we say that we know cosine and we know sine. Those are values represented on our unit circle, but I don't have a tangent in there. So instead I say, well, how do I use what I know about sine and cosine to help me find a tangent value? What we do know is that tangent equals sine over cosine. Okay, that's a quotient identity. So we are going to use our values of sine or cosine. Let me grab my unit circle. We're going to use our values and what we know about sine and cosine to help us find tangent. Okay, what I'm saying is we only have two coordinate pairs, or two terms in that coordinate pair. So I don't have a tangent function in there. So what you essentially need to do is find one coordinate pair in which when they're divided by one another, it equals 1 over root 3. So as we look through our unit circle, I see a 1 to 0. That's not going to work. I see a negative root 3 and a 2, and then a 1/2. This could work. Root 2 over 2, not going to work. And 1/2 root 3 over 2. That could also work. Okay. So no matter what, I'm coming up with these two numbers. This might not be the correct order, but these are the two numbers I'm coming up with. And I have to say which one needs to be in my numerator and which one needs to be in my denominator in order for me to achieve a value of 1 over root 3. So we're going to kind of test this out. If the root 3 is supposed to end up in my denominator, my guess is it needs to be in the denominator to start with. Meaning I would say my cosine value probably needs to be root 3 over 2. Meaning my sine should probably be 1/2. If we set this up 1/2 over root 3 over 2, what we can get to is 1. I know right off the bat, these two are going to cancel. Why is that? When you divide by a fraction, you can multiply by its reciprocal. So I'm going to take my numerator, multiply it by the reciprocal of the denominator. 2's cross cancel, giving me 1 over root 3. Okay, so I'm going to go look this is it. I'm going to go look for root 3 over 2, comma 1/2 as a coordinate pair. But remember in the beginning, we said sine and cosine's period length was 2 pi. If you remember anything about graphing a tangent function, you might remember that tangent period is 0 to pi. So instead of being able to go around the entire circle from 0 all the way around to 2 pi, I can start at 0, but I can only go as far as 2 pi. Only as far as pi, sorry. So what that means is the top half is what I can use. The bottom half is off limits here for tangent. So I can only look above that center line. So I said that tangent could be positive or negative, meaning one of these coordinate pairs could be positive or negative, both could be negative, both could be positive. I'm looking for any signs here. Okay, but it has to be cosine is root 3 over 2 and sine is 1/2. So I want to find that exact coordinate pair. If I'm looking around, right off the bat, I'm able to see at pi over 6. I have root 3 over 2, 1/2. So that's one of them. Keep looking, keep looking. Again, I have it over here at 5 pi over 6, negative root 3 over 2, comma 1/2. So those are going to be my two values, pi over 6 and 5 pi over 6. So all of this work to get to the conclusion that x equals pi over 6 and 5 pi over 6. all of this, this is your final answer. Okay, so this explanation of tangent, I want you to kind of make a note of that. Remember this, when you're using sine or cosine, all the way around the circle. Always, 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 if it's tangent, it's half and above, only this upper half. The explanation part of it, you don't have to give that to me again. You just have to know you can never, ever, ever grab a tangent function from the bottom of this unit circle. Okay. There's a couple more examples I want to show you here. These examples include what's called multiple angle. Okay, so when we're dealing with multiple angles, it's gonna look something like this. Let's say 2 tangent 3x minus 1 equals 0. No, not tangent. I want to do cosine. I'm so sorry. I want to do cosine. Okay, 2 cosine 3x minus 1. So as always, even though this is going to be a little tiny different process in the end, we do every single other step the same. Always start by isolating your trig function. In this case, I'm going to add 1 to both sides to get 2 cosine 3x equals 1. Divide by 2 to get cosine 3x equals 1/2. Okay, now here's the thing. You might be noticing what the difference is here. I have a number in between my trig function and my x. That's not something we've seen so far. When we do see this, what we have to assume is that this angle, what we're solving for, is not actually an angle on our unit circle. So we have to try to find one that's different than that. What we will do is use our unit circle angles to help us find that. So we're going to evaluate this like normal with a tiny little step added on in the end. So whenever you have a multiple angle or this number between your cosine and your x, or your trig function and your x, you leave it. We leave it for now, we're going to worry about it later. So as far as I'm concerned, I've isolated my trig function and all the terms that go with it, which is the 3 and the x. I need to solve or evaluate for where cosine equals 1/2. So we need to go through our unit circle, and we are only looking for positive cosine values. So again, search through your unit circle, and you're looking for positive cosine values of 1/2. So you should get to x equals pi over 3, and then another positive 1/2 at 5 pi over 3. Okay, again, looking around that unit circle to be able to find those. So here's where that different step comes in. All along, you said you have an x equals whatever values you just pulled off your unit circle. That's when this 3 here didn't exist. Now that it's there, we actually solved for 3x. So I'm going to take each of these individually, and I'm going to say 3x equals pi over 3, and 3x equals 5 pi over 3. And I'm going to solve for each of these. Okay, this is the very last step to say, now I divide by 3. When you take a fraction, you multiply by a whole number. It's the same thing as saying, I want to multiply by my reciprocal. The reciprocal of 3 is 1/3. So I'm going to take pi over 3 times 1/3 to get pi over 9. That is one of my x values. I still have to solve over here. We're going to do the same thing by dividing by 3. Take x equals numerator times 1/3 to get 5 pi over 9. There's your second value. Okay, so same process in order to get to that solution, except adding on whatever number is in front of this x, you have to then deal with that and get rid of it in order to get that actual x value. One other kind of form for this. One other kind of form. Let's do 3 tangent, yeah, I like that one. 3 tangent x over 2 plus 3 equals 0. Okay, so the first step here, as always, isolate your trig function. So first step with that, subtract 3. Okay, 3 tangent x over 2 equals -3. Divide by 3, tangent x over 2 equals -1. So the first thing I have to go through and do here is decide where is tangent -1. We have to look at the coordinates on our unit circle and decide which of these coordinates in the same pair will divide and give me 1. So any of these axis pairs won't, because there's 1 to 0, 1 to 0, 1 to 0, and 1 to 0. So those are never going to work for me. Root 3 over 2, 1/2, I also know won't work. 1/2 root 3 over 2, not going to work. It has to be the same number divided by the same number. Looking at this middle coordinate, root 2 over 2, root 2 over 2, that will work for me. So in order for it to be negative, you have to either have a negative root 2 over 2, comma, positive root 2 over 2, or positive root 2 over 2, comma, negative root 2 over 2. So I'm only looking for ones that bring out a -1. Keep in mind, this is a tangent function. We exist with tangent functions from 0 to pi. So you have to look at top half of unit circle. Okay? You cannot be looking at the bottom half of the unit circle. So evaluating for -1, I can only look up top, which means positives are out. I can't have both positive. If I look over here at 3 pi over 4, that's going to work for me. So x equals 3 pi over 4. But this was a multiple angle. I have x over 2. So I have to get rid of this 2 before I can totally be solved for x. If you want to get rid of something in your denominator, you either need to divide by that number or multiply by its reciprocal. So multiplying by the reciprocal of 2 will be multiplying. I'm sorry, I said that wrong. You either need to divide by that number or multiply by, no, that's a reciprocal of that. That makes sense. Okay. So we want to multiply by 2, right? If something is in the denominator and also in the numerator, it's going to cross out. Sorry for my terminology there. That may have confused you, and I apologize for that. What we do to one side, we have to do to the other. So my 2's are going to cancel to give me x. Over here, this is like setting that whole number over 1 and multiplying fractions straight across. So 3 times 2 is 6 pi. 4 times 1 is 4. So when this actually simplifies out, it's 3 pi over 2. If you left it at 6 pi over 4, I would accept that as well. Okay. So those are about the kinds of things you're going to see here. You just have to keep in mind you have multiple angles, and then you also can only be in the top half of the circle for tangent functions. Anything else, really, like this is solving for or isolating a trig function, going and finding that corresponding value on the unit circle. And that's going to be the gist of this entire 5.3. There are many different forms of this. You can see many different examples, but overall, if you are getting an answer over on this right-hand side of the equal sign that you can't come up with on your unit circle, I would go back and check, did you isolate right? Did you subtract or add, multiply, divide? Was all that done correctly? If you are not getting one of those common values found within your unit circle, you might not be finding something correctly. All right, thank you very much.